Functions have a particular language or vocabulary that comes with them. We'll start with looking at the x variable, and that found on a coordinate system is the horizontal axis. And thinking of a function as a machine, my machine says take 12 times x. Into the machine goes a number, and this input is called that number. X goes into the machine, so it's put into the function. So I might let x be 3. The x variable is also called the independent variable because it will determine the value of y. And another real formal name for all of this, instead of calling it x or input or independent variable, we call it the domain. So the domain is just going to be that x variable. The y, you can kind of think of it as opposite of the x. It's going to be the vertical axis. So it's going to run up and down. It then is the output. It is the result of putting x into the function, which is just a rule or a machine. So if my rule was 12x, if x is 3 and goes into my function, out will come 12 times 3, which is 36. We also call the y the dependent variable because it is determined by x. X is the independent, but once I know x, y is dependent. Depends on what x is. And then, just like we have a formal name for x called the domain, we have a formal name for y called the range. So let's go ahead and see how we would write this domain and range. If I had a picture of my rule in a graph form showing all the solutions, notice my solutions start here at x equal 2 and at y equal 1. So my domain then only starts from 2 and goes to my right. So we have a way to write that. We say x is greater than or equal to 2. Looking at my y-coordinate never is below this point. It is going upward. It's heading up this way. As it grows up. And so we say the y is greater than or equal to 1. Never was it less than 1 on that graph. Let's take a look at another graph. We'll start it over at -3 on the x and down at -2 on the y. And my graph goes this direction. Now, if you look at the graph for x, it looks like this U shape continues to go to my right, so x's will get bigger. So -2 has a spot, -1 would have a spot, and it would continue to grow. And also on the other side of this, if I take a look at values that are smaller than -3, like -4, it has a partner. -5 eventually would have a partner, because those arrows mean my graph extends. So because x is horizontal, I always think of it as left and right. Does my domain head to the left and does it head to the right? It does. So in fact, all numbers are in the domain. In this rule, every x can be plugged in. My range, however, does not go up. My range starts at this point -2 and heads down. So every y-coordinate below -2 actually has a partner. So we say that my range then goes from -2 to infinity. So that means y is less than or equal to -2. So you must make sure you know your greater than and less than. Let's look at the last kind of situation here. I have a graph looking like a U on its side. So again, I look at my x's, and my x's start at 0 and head this way. So that means that x is greater than or equal to 0. My y is my up and down. This graph heads up slowly forever, heads down slowly forever, so every y, both positive and negative, map to my graph. So we can say that this is all numbers. Now if we use a vertical line test, this is not a function. At this position, this x pairs with 2. I'm only worried about the input having a unique output. This is a function. A vertical line test only hits at one location, and this is also a function. So you have domain and range, whether it is a function or not. We're going to learn a little bit on how to write domain and range without using inequalities. We have two symbols that we're going to introduce. One is a parenthesis, which means not include. And the second is a bracket, which means to include. And we always write this in interval notation from smallest to largest. And there's another symbol that we're going to introduce, and that is this sidewards 8, and that is called infinity. Now with infinity, infinity is a super large number. You never get there. If I say 1,000,002 is a large number, there's always a bigger number, 1,000,003, and it keeps growing and growing. So I never quite get there, so I cannot include infinity. So looking at interval notation for my first graph, I am going from small to large. I include 2, and I go forever. Not include infinity. For my range, I get to include 1 and go forever. Again, do not include infinity. In the second situation, I have all numbers. That means that x goes from the super small number to the largest of the large. Again, infinity, I never get there. It's not a number. It's kind of an idea. Let's look at the range for the y. We go with the smallest. Negative infinity. Notice I don't include it. I'm going to go all the way to -2 and include -2, but I go no higher. Small to large. In the last scenario, taking a look at my domain and range in interval notation, my x, smallest it's going to be a 0, and it goes forever in the positive direction. And the range goes up and down forever, so the smallest is negative infinity and the largest is infinity. So there's two ways to write my domain and range. One is called interval notation, and the other is using an inequality. Domain and range are nicely found from a graph. When I'm looking at domain, I always ask myself about left and right. Is my function headed to the left, headed to the right? Notice this function stopped at 2. There was no points on the left-hand side. My range is, I look, does my graph head upward? Notice this graph was going up. Does it head downward? No, it does not. The lowest point it gets is y. So this is going to be your range or your y. This is going to be your domain or your x. So you must look at the picture and figure out the directions that your graph is headed.